In today's video, we'll be looking at mole ratios. The objective for today is that you can determine the relationship for the amount of moles of any two substances in a chemical reaction. But let's start with the definition. What is a mole ratio? A mole ratio is just a ratio between the numbers of moles of any two substances in a balanced chemical equation. When we just see the words, that seems a little bit confusing. So let's see what it looks like in an actual chemical equation. Here you'll see something that should look pretty familiar to you. A balanced chemical equation. And in this, you'll see that we've already added our coefficients. 3, 2, there's a 1 here, even though it's not written, and a 3. What these actually stand for are 3 moles of CaSO4. And this actually stands for 2 moles of Na3PO4. So in reality, this entire reaction is saying that if we react 3 moles of CaSO4 with 2 moles of Na3PO4, we will produce a single mole of Ca3PO42 and 3 moles of Na2SO4. So let's go ahead and take a look at an example. Let's figure out the ratio of phosphoric acid to water given this equation. It is already balanced, and you'll see that because I already have the coefficients here, and there's a 1 and a 1. So phosphoric acid, well, from a previous unit, we learned that acids start with H. We know that of all of these, we have this that starts with H and this, but we know H2O is water. So we're going to be looking for this first part at the relationship between H3PO4 and H2O. So the ratio is 1 to 3. And that's moles. And what's the ratio of water to sodium hydroxide? So water to sodium hydroxide, that's going to be a 3 mole to 3 mole ratio. Okay, let's do one more example. Over here, we see a combustion reaction, which has been balanced. So what is the ratio of oxygen to water in this reaction? Oxygen is here and water is here. And we can see by looking at the coefficients that that is a 9 to 6 ratio. So we write 9 to 6 ratio. And in this last one, what is the ratio of water to carbon dioxide? That would be 6 to 6. And we know that because water to carbon dioxide, we have water right here, carbon dioxide right here. They both have a 6 in the front, so it is a 6 to 6 mole ratio. Now let's go ahead and write these as fractions instead of just as ratios. So in the previous slide, we saw that the ratio of phosphoric acid to water was 1 to 3. So 1 to 3. But let's write that as a fraction. So that would be 1 mole of H3PO4 to 3 moles of H2O. And in this second one, what is the ratio of water to sodium hydroxide? Let's find water, sodium hydroxide. So we have water here, sodium hydroxide here. That's a 3 to 3 ratio, but we're writing it as a fraction. So that's 3 moles of water for every 3 moles of sodium hydroxide. Okay, one more. So the same example as from the previous slide. What is the ratio of oxygen to water? That was 9 to 6. So 9 to 6. So that would be 9 moles of O2 for every 6 moles of H2O. And then down here, water to CO2. That's water to CO2. That would be 6 moles of H2O for every 6 moles of CO2. And finally, Y'all go ahead and try this one. Pause the video and hit play when you're ready. So what is the ratio of oxygen gas to water? Here's oxygen, here's water. That would be 11 moles of O2 for every 8 moles of water. And in the second one, what is the ratio of sodium phosphate to calcium phosphate? So sodium phosphate is right here and calcium phosphate is here. So that's a 2-to-1 ratio, 2-to-1, which would be 2 moles of Na3, PO4 2, for every 1 mole of Ca3, PO4 2. And I am so sorry, I accidentally wrote this part incorrectly. That's what it looks like. And that is how you would work those two problems. Thanks for watching.